In this video, I'm going to talk about zeros of polynomial functions. You will be able to identify how many zeros are there, complex zeros, and the degrees of the polynomial functions. So first of all, let's talk about what is a zero. Zero is the same as the roots, which is also same as x-intercept, which is also same as called solutions. Zeros are the x values. Always zeros are always the x values. Now, if we talk about factor, we write zeros as x minus a, which is a linear factor of any polynomial p. Now, what is repeated zeros? Repeated zeros are, we call it multiplicity. And typically we know that the graph of polynomial functions always passes through zeros of the graph. That's where the value of x intercept. However, when the zeros have a multiplicity greater than 1, graph behaves differently. So let's take a look at this polynomial. For example, is a negative zero point zero 0.01 x plus 4 x plus 1 to the third power x minus 3 to the second, and this is the graph given to you. So clearly we can see that the multiplicity of a zero is the degree. Degree means the highest exponent of the factor. So let's take a look at here. The graph is going through negative 4, and we can see that that's the one of the 0. Graph is going through negative 1, which is here, and graph is also going through the 3, which is this factor. So talking about multiplicity means here you can see there is a third power. So here the graph looks like a cubic function. You can see that there are 3 zeros here. X minus 3 to the second power. So you can see that the graph is looks like parabola. So this is a combination of a parabola, cubic function, and linear factor. So what's the degree of this graph? So we can say that there are 3 zeros here, there are 2 zeros here, and 1. So this is a 6th degree polynomial. So how do you know that how many zeros are there? So general rule is if graph changes concavity, here you can see that the graph changes concave up to concave down, then there are odd number of zeros except 1. This is concavity doesn't change. So concavity changes, that means there is at least 3 or 5 zeros. Then if graph is touching the x-axis, for example here, then there are even number of zeros. So it's possible that there are 2 zeros or 4 zeros, because all the even number of degree graph looks like all similar to parabola, and at least 2, at least 3, and 1. So this is at least 6th degree polynomial. So let's take a look at this example here, where we have to identify each of the polynomials, identify the degree, and find the all zeros and multiplicity of each zero. So you can see that there are 3 zeros. So x equal to 0, multiplicity is 3. There are 3 zeros. X equal to negative 1. There is 1 0. If we don't write anything, then it's considered as a 1. And x equal to 4. There are 2 zeros. So we call it multiplicity. Make sure you are familiar with the vocabulary. The word is used multiplicity. So what is the degree of this polynomial? So you can clearly see 3 plus 1, 4 plus 2. So this is a 6th degree polynomial. One more time. 3 zeros at x equal to 0, negative 1, there is 1, and 2 is a 4. So this is the 6th degree polynomial. Now let's talk about here. If we factor this, we have x plus 2, x minus 2. Then we already have x minus 2 to the 4th power. So how this will become is x plus 2 and x minus 2 to the 5th power, 4 plus 1. So we can say that x equal to negative 2, there is a 1, 0, and x equal to 2 multiplicity is 5. So how many degrees are there? So 5 plus 1. This is also considered sixth degree polynomial. Okay, so now sometimes they give you like this and you are expected that you factor. So if I factor out x, I have x square minus x 6, and this can be factored as x minus 3, x minus 4. 6 can be factored again, so you have to factor fully. So which is x minus 3, x plus 2, give you negative 1, x minus 3, and x minus 4. So now let's carefully check how many zeros are where. So there is only one zero at x equal to 0. There is only one zero at x equal to negative 2 and x equal to 4. They are all single zeros. Then x is equal to 3. There are two zeros. So we call it multiplicity 2. So what's the degree of this polynomial? So you can say 3 plus 2, 5, fifth degree. And the degree should match with the number of zeros also. So you can say 2, 3, 4, 5, fifth degree polynomial. Here you can say 4 plus 2, sixth degree. So that means there are 6 zeros, 5 plus 1. I hope you got this concept of number of zeros. You are expected to find it from the equation and from the graph. So for this section, we'll be talking about complex roots. Complex roots means they are imaginary number and you will not see them on the graph. You can clearly see this is a second degree parabola, but it never touches the x-axis. That means no real zeros, which means there are complex zeros. Now, complex zeros are always in the pair. It's always plus or minus I. It's always in the pair. So let's take a look at on the other page. So key understanding is that all imaginary roots come in pair. There is always one and the other one. And a plus bi is a root of f of x. Then a minus bi is also root of the f of x. And they are always in a conjugate pair. They call it conjugate. So this is very important concept. You must understand this for the test, quiz, and the AP exam. Imaginary roots are always in a pair. There are always 2 or 4 or 6 or 8. So let's take a look at the word conjugate. What is a conjugate? Conjugate means the opposite side. A plus bi, then it's a minus bi. So what's a conjugate of 4i? So think about this is 0 plus 4i. So the conjugate is 0 minus 4i. This is a only I, so conjugate is positive I. So remember the complex numbers are is 0 minus I. So conjugate is 0 plus I. 2 minus 3i, so conjugate is 2 plus 3i. And negative 4 minus 2i. I is always plus or minus, so that's what we call them conjugate. Now, polynomial of a degree n has exactly n complex 0 when counting multiplicities. So that's we call that fundamental theorem of algebra, but you don't have to memorize the theorem or anything. You just have to understand that the complex zeros are in multiplicity. Okay, so let's take a look at this example 3 here. If the graph of polynomial function f of x is shown in the above graph, it is known that x equal to I root 3 is a complex 0 of f. What's the degree of n? Now, make sure you understand the format of this question also. Given a graph, there will be a multiple choice question, but here we have to explore the possibilities and look at the graph. So do you see that this graph is touching at x equal to -1? That means there are two zeros at x equal to -1 because the graph touches the x-axis. Our graph is clearly passing through 3 and it is a straight line. So there is a 1 0 here at x equal to 3. Remember, concavity doesn't change, so that it cannot be and doesn't look like a cubic function. It's a straight line. So 2 and 1, 3 real zeros. Now remember, we talked about complex zeros are always in a pair. So that means plus or minus I root 3. If I root 3 is 0, then there is a negative I root 3 is also 0. So there are two complex zeros. They are always in pair. So what's the degree? At least. So this is a n has to be equal to 5. Now in a test, you are supposed to justify and explain. So this is what exactly you have to explain, that there are x equal to -1. There are two zeros. X equal to 3 is a 1 0. Those are the three real zeros and two complex zeros. So n is at least, it says at least. So ideally, you have to write the answer like this, greater than or equal to 5. And this is about the zeros and multiplicity. Make sure to watch the next video for inequalities and other concept.